in terms of writing valence electrons. Valence electrons. In terms of that valence electrons means valence electronic configuration differs. Right. So the position of atoms will be same, the valence electrons position will be different. As a result of that, we'll get different canonical forms will get. Canonical forms will get. Or different resonance structures will get. Resonance structures will get. What is the meaning of resonance? The meaning of resonance is oscillating. The meaning of resonance is vibrating. So here the molecule will move from one canonical form to another canonical form. One canonical form to other canonical form. One structure with other will be resonating in terms of with the change in the valence electrons. And by keeping their position of atoms will be the same. So molecules will keep the position of atoms same, but so changing with the valence electronic configuration and obtaining different canonical forms. So with a different energy, not same energy, one canonical form energy different with other canonical form. So that phenomena what we call means resonance, we can say resonance we can write. So valence electron position will be different, the position of atoms of the molecule is the same. As a result of this, we'll get different canonical forms. These canonical forms have the different energy in their different state. So that is called resonance. Resonance, the meaning of resonance is oscillating and moving. So we'll discuss example for the resonance. If I write C6H6, so C6H6, how many carbons are present? 1, 2, 3, 4, 5, 6. So 6 carbon atoms are present. How many hydrogen atoms are present?
6 carbon atoms.
6 hydrogen. Now each carbon valency in this trivalent. Now for each carbon, how many electrons are left behind? 1 electron each is left behind. So carbon will make how many sigma bonds? 3 sigma bonds. So for each carbon, 1 electron is left behind. They will share to form pi bond. Here एक pi bond, or second pi bond here. Third pi bond is formed. But so is it the benzene real structure? Is the real structure of the benzene? So this is not the real structure. So this is one canonical form. We can write the benzene under structure also. 1, 2, 3, 4, 5, 6. Position of the carbon atoms are same. The position of the hydrogen atoms also same. I am not disturbing. Hydrogen atoms position also I am not disturbing. But what I will disturb means here the pi bond location. This is the pi bond. Now you can see the pi bond location. Here what is the IUPAC name? So 1, 2, 3, 4, 5, 6. Double bond position is 1, 3, 5. Here is, so double bond position if you take like this 1, 2, 2, 4, 6, 2, 4, 6. Here the double bond location you can see now. Here 2, 4, 6, and here 1, 3, 5. So what is the difference between the two structures? What do you make the difference between the two structures? This is one structure. This is Second,
Location of pi bond.
location of pi bond. So that means the position of the pi bond, so not limited to first and the second carbon. Here the position of the pi bond will be moving. Means, for example, here the pi bond can shift here, and this pi bond can shift here, this pi bond can shift here. So this pi bond can shift here again it will go back here, again it will come back. That means here these pi bond electrons will delocalize. So within the ring, as a result of this, we'll get two structures. But which is the correct one? Whether this first one or second one? So both have the different energy. This molecule and this molecule have different energies. So our resonance forms have the energies. That is called resonance energy. But which is the correct structure? Means, so when these two are oscillating each other, so they will be passing through one intermediate one. That intermediate structure is benzene resonance hybrid. The resonance hybrid can be written like this. The benzene resonance hybrid can be written like this. Always the resonance hybrid will have less energy than, lower energy than this canonical forms. So here it has lower energy. So lower energy means stable. So this is called resonance hybrid. So in the benzene ring, within the ring, we are showing the circle with arrow mark. What does this arrow mark indicate? Circle. Within the ring, if I put the symbol circle with arrow mark, means what does it indicate? What does it signify? Electrons delocalization means keep on moving within the ring. So due to this delocalization of electrons within the ring, so the benzene can exhibit aromatic characters, different characters than the alkenes. So due to the delocalization of electrons, one benzene is oscillating with other will be oscillating with this. So two different canonical forms will get, then this is called resonance hybrid disease. Resonance hybrid disease. The real structure one is resonance hybrid. That's why in books you can see the benzene structure will be represented with the circle. Can you see in the book? Are you following?
Yes, sir.
Yes, sir.
So this is the benzene resonance phenomena. Resonance. Now, what did you observe in this resonance phenomena? Pi bond electrons, in some cases, pi bond electrons in the molecule interact with the lone pair of electrons. Pi bond electrons interact with the lone pair of electrons present on the most electronegative atom. This is also resonance effect, we say. Only in some cases pi bond delocalization will take place. Delocalization of pi bond will take place about the atoms. Sometimes the interaction between pi bond electrons and lone pair electrons, conversion will be taking place. Or sometimes what happens means pi bond delocalization will be taking place. So that is also resonance. So resonance in terms of the pi bond and lone pair also we can explain, and pi bond delocalization will explain, and sometimes valence electrons delocalization also will explain with the resonance. So I'll take one more example for this. So how the pi bond electrons will be interacting with the lone pair. Now we can see. If I take only the benzene structure, one more benzene I'm taking. Benzene I am taking. So here is a double bond. Here will be the double bond. Here will be the double bond. 1, 3, 5 location. Imagine on this benzene ring there is one electronegative group. NH2 is there. NH2 is there. On this nitrogen, one lone pair is there. One lone pair of electrons are present on the nitrogen. So here this nitrogen is more electronegative. Here is the carbon. 6 carbons are there in this. This is a ring. So here what happened now you can observe this lone pair will interact with this pi bond. Will cause resonance effect. Will cause the resonance effect plus or effect we say. So what is this? You can see now. The NH2 group present, this is called aniline. What is the name of this compound? Aniline. So when this lone pair will come between this nitrogen and carbon. See look at the arrow mark. I am representing this arrow mark. Head of this arrow going toward the carbon. Tail of the arrow source of the electrons. Now I am indicating like this means electrons are coming between the nitrogen and carbon. Guess what happened next? On the nitrogen, what kind of charge will be formed? Positive or negative? Positive. Here will be the double bond. समझ आ गया सबको? Are you seeing what I am telling? The lone pair
Yes.
present on the nitrogen coming between nitrogen and carbon. क्या होगा? Means what happened to this pi bond electrons? Can you guess? So this lone pair will interact with this pi bond means the pi bond get repulsion or not?
Yes, sir.
Yes,
So
sir.
then this pi bond will come out on the second carbon. This negative charge is formed. See, and here as it is, here it is as it is. I am writing. Can you see everyone? All of you, are you seeing what I am writing?
Yes, sir.
Yes, sir.
So
Yes, sir.
now this lone pair present on the nitrogen interacting with this pi bond electrons present within the ring. When the lone pair of electrons coming inside means between the nitrogen and the carbon, the pi bond get repulsion moving on to which carbon? Second carbon. But my question is how long this negative charge will be residing on the second carbon? Only few fraction of seconds. Again this negative charge try to come inside. When the negative charge means negative charge matlab two electrons we say. one lone pair electrons. So pi bond is converted to lone pair. When lone pair try to come inside, when the lone pair is converted into pi bond, so this pi bond get repulsion. It will be moving on to the fourth carbon. So now you can see the resultant structure what I am writing. Positive, negative charge. What is moving? Can you tell now? Negative charge is moving within the ring or not?
Yes, sir.
So, but is it negative charge is a permanent here on this? Negative means two lone pair of electrons. Is it permanent? No. It will come inside again, causing the repulsion. This pi bond will move on to this which carbon? Sixth carbon. So here next to structure I am writing. Dekha, you also write these structures in your book so that it will become practice to you. Because now how long this negative charge will be residing on the sixth carbon? It will go inside again. When this negative charge will go inside, what happen? It causes repulsion to this pi bond. So what structure do you get now? You can see did you get the same?
Yes, sir.
Yes, sir.
But
Yes, sir.
but identify the location of the pi bonds. Compare this and this one. Difference is there.
Yes, sir.
Pi bonds location here, pi bond locations, both are different, but both are same structures. So as a result of this, how many different structures are you getting? 1, 2, 3 canonical forms are you getting or not? 3 different resonance structures are you getting or not? That means here,
Yes.
when the lone pair is interacting with this pi bond electrons, what is happening means this molecule is undergoing changes. This molecule is oscillating from resonance 1, resonance 2, resonance 3, and finally again you are getting one same structure or not?
Yes, sir.
So why this is happening means if the pi bond containing carbon is attached to the group, which group it is attached? NH2 group, electronegative group. So this electronegative group is nucleophilic character. So this nucleophilic character, when this lone pair is interacting with this pi bond, so then we are getting the resonance structures. That means, so the molecule is transforming or changing from 1 to 2 to 3. 3 resonance forms it is undergoing. So as a result of this, due to the interaction between this lone pair and pi bond electrons, what happened? The molecule is undergoing changes. So meanwhile, it is spending some time. So that molecule will be the stable, or the due to, and during the reaction time, what happen means if the negative charge is here means that it will attract the electrophile. If the negative charge is here means it will attract the electrophile, it can form the compound with the para position, ortho position, meta position, ortho position it can form. So this is the plus R effect, positive resonance effect we say this is. That means on the benzene ring any negative electronegative atom is there, this kind of change will happen. Okay, so now this is one example I want to discuss this plus R effect, positive resonance effect. Resonance effect otherwise called mesomeric effect also. Now imagine on the benzene ring, NO2 group is present. NO2 group here, this is the structure of NO2. This is the NO2. So on the benzene ring, there is NO2 group. On that NO2, 2 oxygen atoms are present. One oxygen atom having lone pair, other atom so pi bond. So and so here this is a benzene ring. Now here this NO2 molecule present on the benzene also will undergo resonance effect. So how the resonance effect will takes place? So generally what happen, this nitrogen, so nitrogen is the, but here nitrogen is electron deficient here. So what the nitrogen will do means, so here the electron pair will go, this pi bond is going on to this oxygen. If the oxygen become negative, more negative, the oxygen will become more negative, means here nitrogen will become positive. So when the pi bond moves on to the oxygen to form the negative charge, the nitrogen will get the positive charge in the presence of external reagent. So when the nitrogen gain the positive charge, what happened means this pi bond will, what happened to this pi bond? This will go between the nitrogen. So as a result of this, you can observe what I am writing. Now you can guess what kind of charge on the benzene ring, positive or negative.
Positive.
This pi bond is going here between nitrogen. This positive charge is cancelled here. Then where will be the positive charge? Wake up. Are you seeing what I am writing on the board?
Yes, sir.
Yes, sir.
Yes, sir.
So the pi bond is converted, the pi bond is going between nitrogen and carbon, and here on the second carbon, what is the charge is formed here?
Positive charge.
Positive charge, carbocation is formed here. But how long this positive charge will be here? Now this pi bond will come here for compensation of the positive charge. Then guess where could be the positive charge again? Did you guess where the positive charge is formed? If this pi bond is moving here to neutral this positive charge, then here will be the positive charge, no?
Yes, sir.
Now this negative charge will come back here to neutralize this positive charge. Now next step, you can tell me where will be the positive charge on which carbon? समझ में आ रहा है सबको?
Yes, sir.
Next. This pi bond will come into the ring. This pi bond will come inside the ring to cancel this positive charge. Then again this negative charge will come back. Then between nitrogen, oxys and double bond. So then आपको मिला same structure, वही structure same. First one. This negative charge is coming back. This pi bond is going into the ring. Then this positive charge. So this positive charge is disappeared. Clear everyone?
Yes, sir.
So what
Yes,
really
sir.
this NO2 group is doing means the NO2 group is taking away the electrons. So this NO2 group is called electron withdrawing group. Electron withdrawing group we say. So as a result of this NO2 group, what is happening in the benzene? The benzene ring is becoming electron deficient. Electron deficient. The benzene ring has become electron deficient because NO2 group is, because of the resonance, NO2 is taking away the electrons. So in earlier case, what happened earlier case, on the benzene ring, negative charge is formed. Negative charge was formed in the earlier case because of NH2. So because NH2 was releasing the electrons into the ring, but NO2 is not doing like that. What the NO2 is doing? Taking the electrons from the ring to outside. But what NH2 was doing? NH2 was releasing electrons into the ring. Then ring will become electron rich. So in one case benzene is becoming electron rich. In other case the benzene is becoming electron deficient. As a result of this, what happened means the benzene will undergo various forms. various canonical forms, various resonance structures. Number 1, number 2, number 3 resonance structures it is undergoing. So that is due to the substituent present on the benzene ring. So here from this what we can understand means some of the groups, some of the substituents present on the benzene ring will influence the reactivity of the benzene, will affect the reactivity of the benzene by decreasing electrons, by increasing electrons. Such groups, such substituents are called, so this is electron withdrawing group we say, and some are electron releasing groups. So what are the electron releasing groups? Electron withdrawing is NO2, COOH, CHO. These are the electron withdrawing groups we call, and electron releasing groups are so chlorine, NH2, CH3. So these are the electron releasing groups. Chlorine, iodine, NH2, CH3. That means the substituent that is present on the benzene ring also will affect the reactivity of the benzene. They will direct the electrophilic substituent or any substituent to attack on the benzene ring. Where to attack? On ortho position, on the para position, on the meta position, where to attack, these groups will decide. Such groups are called electron withdrawing groups and electron releasing group. Electron releasing groups will follow the plus R effect. Electron withdrawing group will follow the minus R effect. So here what I explained is because of resonance effect only. The interaction of the lone pair with the pi bond electrons. The interaction of the lone pair with the pi bond electrons, as a result of that we'll get so many resonance forms we'll get. More are the resonance forms, more will be the stability of the molecule. Less of the resonance structure means less will be the stability, matlab unstable we say. Stability of the molecule explained based on the resonance forms. Stability of the molecule can be explained based on the resonance energy. Got it everyone? So here because of this NO2 group, because of the lone pair will interact with the pi bond will interact with this benzene ring pi bond electrons, then we'll get the resonance forms. So these are the resonance structures we get, and the benzene structures we can write. I hope it is clear everyone.
Yes, sir.
So resonance effect, and one more molecule I want to explain to you. What is the name of this compound? Nitromethane. Nitromethane. Only one is speaking, Sandeep only, others are not speaking. At least you can say yes or no means then I will do the follow-up. Otherwise, whatever I'll teach on this board that goes, so like without resonance, without inductive effect, without electromagnetic effect, no influence on you. I hope some resonance should be there with you.
Yes, sir.
Yeah, Pranilji.
Yes.
Aryan. So this nitromethane, I can write nitromethane like this. Nitro. This is coordination covalent bond. Is it nitromethane? So one more nitromethane will be C. So here one more nitromethane I am writing CH3 NO. Here will be the double bond, here will be the two are resonance forms or not? Two are
Yes,
resonance
sir.
forms.
Yes, sir.
Yes,
Yes.
So here, what happened here you can see. One of the pi bond converted into lone pair here. One of the lone pair is converted into pi bond.
Yes, sir.
Got it? So resonance. We can write this resonance. Or else you can see now how this resonance will happen. You see, this nitrogen will get the positive charge because of this shifting of this pi bond, conversion of pi bond to lone pair. So a negative charge आएगा, either positive charge आएगा, then this pi bond will disappear. So in the here, if one extra electron pair will come, means negative charge आएगा इधर. Then in order to compensate this positive charge, one of the lone pair will come back. Then इधर pi bond बनेगा एक. Now either two pi, one pi bond, one sigma bond. So ये structure आएगा. Now the positive charge will disappear. Negative charge will disappear. Got it?
Yes, sir.
So
Yes.
now nitromethane has two resonance structures. Nitromethane has two resonance structures, we say. Okay, so that's you can already you learnt about the resonance phenomena, ozone formation, ozone molecule, and next one is last one is hyperconjugation. I will close with this hyperconjugation phenomena. So what is hyperconjugation means? Hyperconjugation means which is one special phenomena of carbocations. Carbocations. So carbocations will exhibit hyperconjugation phenomena. Or hyperconjugation is useful to explain the stability of carbocations. It is stabilizing factor. Stabilizing factor, we say. It can help in the stability of the carbocation. Hyperconjugation. And what is hyperconjugation? I am telling now. Just the hyperconjugation is nothing but interaction of sigma bond electrons of carbon and hydrogen of alkyl group. Listen carefully. Sigma bond electrons of alkyl group. So sig means the interaction of sigma bond electrons of alkyl group to adjacent unsaturated carbon atom is called hyperconjugation, we say. This is otherwise called no bond resonance. Also we say. No bond resonance phenomena we call this is. Hyperconjugation is, it is the interaction of sigma bond of alkyl group. So with the pi bond, here I wrote unsaturation. So with the pi bond of adjacent carbon is said to be what we call means hyperconjugation, or it is said to be otherwise called no bond resonance, we say. So no bond resonance. So with this hyperconjugation, we'll explain the stability of carbocation. So how we can explain now, you can see. So here you can see what is the molecule, what is the carbocation I'm writing. What is the radical? This is carbocation.
So methyl.
Methyl. So, and in this methyl, is there any double bond? Or so in this methyl cation, is any alkyl group? Is there any alkyl group adjacent? Is that positive charged carbon is attached to any methyl groups, any alkyl groups?
No,
No,
sir.
sir.
So here in this there is no hyperconjugation. In this molecule there is no hyperconjugation. Next, another carbocation. Here I am writing So what is the name of this carbocation?
Ethyl carbocation.
Carbocation.
This is ethyl carbocation. So I told already 1 degree carbocation I told no. So this 1 degree carbocation is attached to one alkyl group. One alkyl group is there. One methyl group is there.
Yes, sir.
Yes, sir.
So this methyl group is said to be alpha carbon. This is alpha carbon. Adjacent to this carbocation, carbon is said to be alpha carbon. This is. And these hydrogens are called alpha hydrogens. याद रखना. This is alpha hydrogen. This is alpha hydrogen. This is alpha hydrogen. This carbon is alpha carbon. This is not alpha carbon. This is alpha carbon. Now, what is hyperconjugation means? This positive charge present on this carbon atom will influence the sigma bond, this sigma bond, this sigma bond. This is CH bond. This is CH bond. How many CH bonds are there? How many CH bonds are there? 1, 2, 3 CH bonds are there.
5.
So sigma bonds, how
5
many are there? Sigma bonds, 1 sigma, 2 sigma, 3 sigma, right? So here the positive environment will affect the sigma bond of CH, sigma bond of CH, sigma bond of CH. So how will be that effect? What is that effect means? So this positive charge, matlab here positive charge means this carbon has empty p orbital, no pure p orbital is present or not in this carbon. So empty pure p orbital, already I told you sp2, this is sp2 carbon, this is sp3 carbon. So and this sp2 carbon has one pure p orbital, empty one. So this pure orbital, empty p orbital attract the sigma bond. Due to this positive charge, this sigma bond will be oscillating and moving. Finally, it will convert into the double bond. Now you can see. Got it? Saturation bond changed into unsaturation or not here?
Yes, sir.
So now positive charge disappeared.
Yes,
Single
sir.
bond became into double bond.
Yes, sir.
Then you will ask question, what about this proton? So this proton is taken by, abstracted by any base during the reaction, any base, or else in case any base is not taking, what happen, you know, guess interesting thing will happen. So when this proton about to move from this carbon due to lack of the bond, इसलिए मैं बोला no bond resonance बोला. Between this proton and this carbon there is no bond. Still the proton will be lying there only, waiting for this sigma bond to sacrifice. So what happened means this sigma bond, so this sigma bond will be, now you can see, this will become the proton, here bond is formed. And next here it will make the bond, the proton shifting will be here. So like that, how many structures we can write? Do we write 3 structures?
Yes, sir.
Yes, sir.
Yes, sir.
So now this molecule, this carbocation will have how many resonance forms? 3. So one is here, other one is, so this proton. So like that we'll get the 3 resonance forms. Got it? And means for the 1 degree ethyl cation, carbocation, we'll get the 3. Now I am writing two degree carbocation. How many resonance structures will get?
4.
ध्यान से देख लीजिएगा. So CH bonds how many here?
6 structure.
CH bonds how many here? So this CH bond is alpha, this CH bond is alpha, this is also alpha, this is alpha carbon, and here also this is also alpha carbon, here is alpha sigma bond. So these three will be interacting with this positive charge, these three will be interacting with this positive charge. आपको कितना resonance hyperconjugation structures आएगा? How many resonance forms you'll get? How many hyperconjugation structures you'll get? Like this.
6.
Sir, 6.
So it means this sigma bond will sacrifice to form double bond here. Positive charge निकलेगा, इधर positive charge आएगा. Then this positive charge will be shifting to this hydrogen to form the double bond. In case here these hydrogens will take part in the hyperconjugation, means either double bond banega, either single bond. Got it? Now either positive charge aayega. Like this, how many sigma bonds are there? Carbon hydrogen sigma bonds are there. That many resonance hyperconjugation structures will get. So the CH sigma bond will interact with the positive charge or with the pi bond. So this is said to be hyperconjugation, we say. Are you understanding what I am talking about?
Yes, sir.
Yes, sir.
Now last one. What is this? What is this?
Fine carbon.
T-butyl carbocation. Is it T-butyl carbocation? So this positive charge will influence this CH, this CH, this positive charge will affect. This positive charge will affect. Now tell me, how many CH bonds in these molecules are affected by or interacting with the, so interacting with what means with the pi bond? Pi bond formation?
9.
9.
So this carbocation undergoing 9 hyperconjugation structures. 9 hyperconjugation structures. So 9 means this ion will be staying longer time or shorter time? Tell me.
Shorter time.
So this ion means this positive charge interact with the sigma 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will take long time for this changing. It will take long time or not? Comparison with this 2 degree, comparison with 1 degree, comparison with this methyl cation, which will take longer time.
This one.
3 degree resonance.
So the carbocation which exhibit more hyperconjugation structure is the more stable. The means the carbocation not having any single means resonance structure. Matlab only one resonance means this not having any resonance. So this is unstable. Unstable. Clear everyone? So this T-butyl carbocation, so when these CH bonds, this sigma bond is converted into pi bond here, so you will get pi bond formation here. So either proton आएगा And second one, the proton positive charge shifting to this hydrogen. So here is the bond, here will be the proton banega. 2, 3. Now pi bond formed or not here, sigma bond is converted to pi bond or not, then positive charge will disappear. The same thing will happen here also, the same thing will happen here also. As a result of this, T-butyl carbocation will undergo 9 resonance, 9 hyperconjugation structures. It will spend a lot of time, comparison with 2 degree, 3 degree and 1. So that's what I wrote the stability order. T-butyl carbocation more stable than the propyl carbocation. Propyl carbocation is more stable than the primary. Primary is more than the methyl. So in this 9 resonance structures, in this 6, in this 3, in this 1, 9, 6, 3, 1. That is the order. So the sigma bond of alkyl group, sigma bond. This is alkyl group. में बोला क्या बोला? ये वाली alkyl group में बताया. ये वाली alkyl group. How many alkyl groups are there in T-butyl carbocation? In T-butyl carbocation, alkyl groups how many?
3.
1, 2, 3. Each alkyl group containing how many CH bonds?
9.
3 CH bond.
So to all together 9 CH bonds.
Yes, sir.
Yes.
So all these will interact with the pi bond between this carbon. So that is called hyperconjugation. It is otherwise called no bond resonance. So this no bond resonance can help this carbocation to stabilize temporarily during the reaction intermediate. During that where, so these are all produced during the, so what we say means as a reaction intermediates. These are not the products. So these are the reaction intermediates. Before formation of the products, so these ions are formed. Got it?
Yes, sir.
Yes, sir.
So hyperconjugation and this over. Resonance also, in case any doubt is there, we'll further we'll discuss later in the revision class about this. So and this topic, see, methods also not there, only up to this hyperconjugation resonance is there. And again, so we'll start organic chemistry, one more topic, hydrocarbons will start. So and you can do the follow-up reading. So as per the revised syllabus, methods and techniques of synthesis, purification are not there.